All right. In the last part of the talk, as I said, I'm going forward with what are we going to do? What are we doing? What we did, and in the Mathematical Modeling of Emotions project, or MME. So, who is involved? So, Ayman Balti is a postdoc. Hassan Wad is an engineer. And so Aziz Alawi is a professor of mathematics. Abdelatif Ujbara is a PhD student, and we will have also uh, graduate students that will work this summer. And we had a collaboration with a private company, and another is coming too. So what we did so far is that so we had more than 100 participants, and what they do basically they leave some experiment in virtual reality headset, and while they are visioning and living this situation, we record EEG and PPG, heart rate, body temperature, and skin conductance. And at the end of the scenario, which lasts like 2 minutes, we have also a questionnaire related to the situation, the event that they lived. So this provides data that can be further analyzed and correlated with, in particular, emotions and psychic states, and with respect with what they saw, what they lived in the virtual reality headset. So yeah, basically you have the EEG signal. So there is some signal analysis to do. So you have some stuff that is very connected to the EEG. So and then you can do some classification. And for example, here it's the SVM method. And you have also the questionnaire, so you can use some AI to interpret the questionnaire with respect with what we want to conclude. And so our postdoc is currently analyzing this the data coming from this 100 participants, and to find some patterns in the data. So we'll have also some a PhD student who will join the team for a few months, as well as a graduate student, and they will work on PDE models to connect with the EEG. And so that's the project. Correlated to that, what I didn't speak so much about uh, is that now, when we record the frequencies in the brain with the EEGs, so your frequencies, and this has been studied a lot. For example, in during sleep, right? And for example, in PTSD, there are some frequencies that are known too. And in this paper, they provided a network. And in fact, this network, a mathematical model. So they use an in silico model, which is in fact a network of ordinary Hodgkin-Huxley differential equations. In fact, there are some stochastic components in it, so it's not exactly ordinary. Uh, But then we can use our skills in math to try to analyze why they're using this model. Why is it relevant to provide those frequencies that are further related to PTSD? And that's the PhD thesis of Abdel Ujbara, who participates also in the MME project. Um, and here, for example, it's an analysis that he has done at the beginning of this PhD thesis, and it just emphasized the fact that you can have some chaotic behavior uh, in a single HH model when so HHH is Hutchin-Huxley, uh, and when you just drive this single HH with a time-dependent I of t. So what you see this movie is the evolution of the trajectory within the attractor of a single non-autonomous Hodgkin-Huxley equation, right? All right, and so this is relevant within the context of non-invasive brain stimulation. So within there, you have so recordings from the brain. You have uh, field models, which are PDEs. People are trying to do network of ODEs, excitatory and inhibitory uh, networks. And what they try to do is also to stimulate the brain at some frequencies. And uh, people are saying that this provides some results, uh, but this is a field, an ongoing field of research. So now we spoke about a lot of things. So we started with emotions, which are ubiquitous. Uh, and now we ended up with how to classify, use the measurements, the data. So here in the last slide, I just summarize what are the big things that we are using. So we try to connect data using AI, statistics model classifications models, uh, neural networks, and dynamical systems to go all the way from measurements to uh, mathematical representation, modeling, and visualization of emotions. So that's what I wanted to say. Thank you and thank you for your attention.